Well, today in this video, or this lecture, we're going to look at waves. And you can think of a wave, if you've seen a water wave or whatever, but you can think of a wave. It carries energy. It carries energy. Through matter. And sometimes you'll hear the term through a medium. And we'll put this in parentheses here. You know, a medium could be water, could be air, could be steel, whatever it happens to be. Without taking the matter with it. Taking the matter with the wave. You know, if you're going to the beach and you see the waves hitting the shore, the waves kind of go up and down, but the water doesn't pile up on the shore. The energy of the wave goes through the material, but it doesn't take the particles of the material with it. Well, we're going to look at the two basic types of waves. And the first one we're going to look at quickly is called a longitudinal. Or a compressional. This is essentially the best example is a sound wave. Sound needs something to go through. You don't hear sound in the vacuum of space. All those space movies are kind of boo-hooey because you don't hear sound in space. But let's quickly look at what a sound wave is. We'll see if we can put one out here for you. All right, our best example, we'll do this in class, is I have some real long slinkies. So when you compress the coils together, what you have is they spread out and compress. Spread out and compress. And this is essentially a sound wave or a longitudinal compression wave. In a longitudinal / compression wave, the particles, well, we'll start off this way. The wave moves parallel to the direction the wave is traveling. The wave is traveling. I think it's double G in there, maybe it's not. So what this is saying is, as the wave moves in this direction, the particles of the wave are moving in the same direction. And for a longitudinal wave, that is what happens. And we'll see this when we do the slinky on there. We're not going to say a whole lot about these, but essentially remember that this is a sound wave. Alright, the next general type of wave, and the one we're going to spend some time on, and this is going to be a transverse wave. And this is what we typically think of a water wave, and essentially light is a transverse wave, and we'll do a lecture here on a light pretty quick. Oop, I think I put water in there, and it should be wave in there, so let's get that out of there. And we're talking about a wave, a transverse wave. In a transverse wave, the particles particles move perpendicular to the direction of the wave. To the direction of the wave. And let's see if we can draw one here real quick. So let's just say this is, quite often you'll see the term line of equilibrium or origin, a line of rest, you'll see the term called sometimes. And let's put a transverse wave in there. So you get a different color here. So you can see the particles of the wave are moving perpendicular, to the direction of the wave. Particles of the wave are moving perpendicular to the direction of the wave. And what you have, if the wave is moving in this direction, the particles are moving up and down. And so when you think of a transverse wave, really think of a water wave. Well, there are some basic terms we need to know here as far as parts of the wave. And let's go ahead and look at, we'll draw a better one here. Let's see if I can move this back over. Where we go here. And let's put it on there. Alright. Let's put our line of origin in there. And let's see if I can find a nice little color for the wave. And this is a nice transverse wave. And let's look at some basic terms here. So we've got our transverse wave, particles are moving perpendicular. And let's look at some terms here. The top part of a wave, and you can think of this up here, this area from here to here, or if it's the area from here to here, is called the wavelength. Is the wavelength, represented by that Greek symbol. And the wavelength typically is from the crest to the crest. The top part of the wave is called the crest. And this would be another crest. Or from trough to trough, and the bottom part of a wave here is called the trough. You know, horses drink out of a trough, crest, toothpaste. So when you start talking a wavelength, it's from crest to crest, trough to trough, or it could be from any two same parts of two successive waves. Could be from this point here to that point, but typically it's just fine. You find it from crest to crest and trough to trough. The other key here on a wave, and people get a little bit confused, is, let's see if I can get a different color on here for you guys, is what's called the amplitude. And the amplitude is from the line of origin. The line of origin, so this is the amplitude. This is the line amplitude, is from the line of origin to the crest or the trough. It is not wave height. When we start talking wave height, especially talk about a water wave, would be from the crest to the trough. So when you start getting from here to there, that you would think of as the height. But when we start talking these types of waves, we're really talking about from the line of origin or line of equilibrium, this line right here, to the crest or the trough. Alright, I think that'll be good for this one, and then we'll come back with wave speed on the next one.